Okay, very good. We've been going with this Annex data-driven smart buildings for about a year now. And, we're interested in the operational phase of buildings and reducing wastage of energy through poor operation. And so this is very much around real-time data for managing equipment things. The US Department of Energy Smart Energy Analytics campaign showed that over 6,500 buildings, typically you could achieve savings after 2 years in the order of 9%, and at payback times of around 2 years. So there's a whole lot of low-hanging fruit there in terms of energy and emission savings potential. But also operating in real time, we're able to investigate flexible demand as a resource from buildings in so-called interactive efficient buildings. And so I guess the key question in this annex is, can digitalization as the technology toolkit unlock energy savings and flexible demand? And you would ask the question, well, what is digitalization? There are a bunch of different names that are used, such as Industry 4.0 or smart buildings. And when I think of this, I think of the loop that takes from data capture through to management of data, applying data analytics to the data, and then utilizing the analytics to make informed decisions. So very much a data to decision making. And in the energy efficiency world, we've always understood that you can't manage what you don't measure. And so we have quite an understanding that there needs to be energy metering. But what we're saying in this particular annex is that we actually want to bring together more than just the energy meter, but data from the building management system in buildings and from new emerging Internet of Things sensors and devices, and capture that data, federate it in the cloud, and make it accessible and discoverable using modern semantic web technology techniques. Once we have that data assembled and brought together like jigsaw pieces into a jigsaw puzzle, we can start to apply the data mining, artificial intelligence, machine learning style algorithms. Of particular interest for us in this annex are model predictive control for optimizing energy consumption, fault detection and diagnosis, and as I mentioned before, grid interactive buildings providing flexible demand for the management of the variability of renewable energy supply. But none of that makes any sense if you can't bring it back and dispatch your flexibility or enact some form of command back to building. And so there is a need for I guess, the human interface to be able to intervene where necessary, but an ability for the machines to talk to the machines to enable action. And if you get this loop from data right the way through to analytics and decision, you end up with a platform with many stakeholders collaborating together to deliver the energy efficiency and flexible demand. We know of platforms such as Uber and Airbnb as platforms that buyers and sellers sit upon, and it's that kind of platform arrangement that brings people together, that takes you all the way from the energy metering to reduced energy consumption. So I guess what we're looking at as the platform for us is the energy management information system. It is more than the energy meter, it's the complete ecosystem that brings energy efficiency to the building. And so the kind of features that you get out of it or attributes are increased transparency for transacting energy efficiency, all the power of modern mathematics techniques, and connectivity to enable actions to be taken. In case of flexible demand, you'd be looking for markets to provide price signals to drive flexible demand. But ultimately, to get a scalable solution, you need machines to be able to talk together and automate the process. So this is the kind of domain we're working in, but what we realize is that there are a lot of barriers to that. At our recent plenary meeting, we did a poll of a large number of our participants there, and we found that there are still issues around hardware, software interoperability, devices that cannot talk to each other because they're using different proprietary protocols. But more than that, there's difficulty actually even knowing what a given data stream actually is. It's all very well to get a 4 to 20 milliamp signal, but what does that relate to in the building, and what are the things that are influencing it? So it's that whole discoverability of what that data stream actually means, which requires a lot of standardization as well. Cybersecurity is clearly an issue for the real-time operation of buildings, and IT departments will make that difficult due to the conservative nature of the industry. Indeed, the HVAC industry is broadly seen as a laggard in the adoption of digitalization. We have a range of skills barriers that come into play as well. And when technicians go out and they are tagging up data streams, they can use quite diverse practices for naming of data streams that make it very hard to come back and understand what's happening. And there are a range of commercial barriers there around vertically integrated service providers that create lock-in, which is quite a problem for the purchasing department. And overall, there's sort of a lack of clarity what even this digitalization thing is. And what we found was that it's poorly understood what a digital ready building is. That is a building that has got sufficient digital capability to enact modern energy efficiency and flexible demand software applications. And if you were to go out and write a tender spec to actually to buy one of these things, you probably get as many different solutions offered as you have people tendering. So some level of understanding even smart building is from the concept of energy efficiency and flexible demand. In terms of our annex, yes, we're a community of practice around the digitalization, but we're working particularly on data management standards and the platforms that instantiate those standards. And we have a number of researchers developing software applications which we are benchmarking in test environments or digital twins. We come from Mission Innovation as our sort of foundation, Mission Innovation 1.0, and so we've always come to it with a desire to drive innovation in software as a service applications, and so collecting data, creating the data sandpits, and then running competitions is something that we value highly. Just the mechanics there. The annex is structured into 4 subtasks. One is around the data itself and the mechanics of the data collection. It includes discussion around data governance and how data should be managed and who should have permission to access data. About the data platforms that enable all this to happen, and the data information models are the sort of standardized ways of representing data in the building in the operational phase. Subtasks B and C relate to the machine learning type techniques of model predictive control. fault detection and diagnosis, and building to grid or interactive buildings. And subtask D is the dissemination side of that. We're collecting case studies, and we have an aspiration to investigate business models as well. We've got 19 countries, 50 odd organizations, and so we have we've had significant collaboration despite the COVID conditions we've been operating under. And we've completed our first competition there, run out of University of Texas, Austin. That's looking at reinforcement learning as a technique for dispatching flexible demand or storage from clusters of buildings. We're now helping to support the Hong Kong EMSD, which also has a global AI challenge for buildings with more than $150,000 worth of prizes. And we have a funding application into ERANET, looking to sponsor some additional competitions to drive innovation. So just in conclusion, I mean, for us, well, what would success look like? Well, just imagine if you could download energy efficiency tools like you download an app on your mobile phone. Wouldn't that be super cool? Yeah. And now who would like to go first? Nah. Unfortunately, our buildings industry is a laggard in this space of digitalization, and so we're investigating things like Smart Readiness Index and that as a way of trying to support policies that would encourage the adoption of digitalization as a tool to achieving energy efficiency. So it's a bit of a yeah, nah, or yes, no. Yeah, nah is a bit of an Australianism, and I think it means, yeah, we really get it. This is really important, but don't let me be the first one, which perhaps is a little bit like Australia's climate policy. So I'll leave you with that, and I will pass on to Professor Akashi to give some practical examples of what